Hi, welcome to this video. It's on load calculations. More specifically, it's going to be for branch circuit conductors, and over here we have the overcurrent protection. Okay, now they both read the same. You have the ampacity not less than the non-continuous load plus 125% of the continuous load. They say the exact same thing. Not less than the non-continuous load plus 125% of the continuous load. Okay, and this right here, the minimum branch circuit conductor size shall have an ampacity not less than the maximum load to be served of any adjustments or correction factors in accordance with 310.15. So if we have when we do our temperature derating, that's why we need to determine if it's continuous or non-continuous when we do our temperature derating. We don't have to do that when we do voltage because your currents or your heat's not going to change, or I should say your voltage will not change once your load is energized. Okay, so let's just move on down here and and we'll go ahead and get started. Before we do get started, I want to point out B here. It says conductors of branch circuits supplying more than one receptacle, so that means a duplex receptacle is more than one receptacle. So anytime you power up one receptacle or feed one receptacle, you're following here. Where were we? Oh, the conductors that feed more than one receptacle for a cord and plug connector, portable loads, key there is portable, shall have an ampacity not less than the rating of the branch circuit. That's why we can take our receptacles and figure into the max branch circuit. So we can figure it into a 20 amp breaker. Okay, unless they tell us it's continuous, right? But all right, let's come over. We'll start right here. So if we got a 16 amp load, all right, non-continuous, let's specify non-continuous, that's at 100%. 100%. So anytime we multiply it by percentages, we got to move that decimal to the left 2 places. So 16 times 1 gives us 16 amps. Well, that's the conductor for that would be a number 12. Okay, we can't do anything less than 12 for 16 amps. Okay, now there's not a standard size 16 amp breaker, so the next larger one that we're allowed to go up to is a 20 amp breaker. Okay, so again, your conductor's got to match your breaker. Okay, now let's do continuous load. We got a 16 amp load. We're going to multiply it by 125%. Okay, oops, percent. There we go. So we move the decimal over 2 places, so we get our 1.25. We multiply it out, and we get a 20 amp load for our conductor. So we need a number 12. Okay, and we're not paying attention to our 110.14 because at this time we're just trying to get this this process down. Now, there is a standard 20 amp breaker, so we can put that on a 20 amp breaker. Okay, we can't put it on a 15. The code up here says not less than. Okay, so we can put that on a 20 amp breaker. So let's do this. Let's say we have we'll go 30 amp breaker. Okay, we got a 30 amp breaker. What's the max continuous load can we put on? The maximum continuous load. Continuous. Okay. Excuse me. So we're not going to multiply like we did over here because here we had our load and we had our 125 and that gave us our, I don't want to call it load, but final amperage, final amperes, or we could say possibly in our example, well, we'll just go with final amperes, okay? So we're trying to figure out what we can load, our max load can be on a continuous load is on a 30 amp breaker. So if we knew our load, we could multiply it by 1.25, and that would give us our 30 amps. That's the max amps, right? Whether it's continuous or non-continuous, that's the max amps, because that's what the breaker's set for. So we just simply do our basic algebra, divide both sides by 1.25, and our load, we take 30, divide that by 1.25, and we get, there it is, we get 24 amps. Okay? Now, I'm going to show you another method. Instead of using this formula, okay, if we take 30, that's what our breaker is rated for, or our max breaker, breaker, and we take that times 0.8, we find that's also equal to 24 amps. Whoa, it freaked out on me there. There we go. I'm back. So here, 24 amps. Okay. So you can pick which one you want to do until you get comfortable. Until you get comfortable with this, I would not do this method. Okay. That'll just probably mess you up. When do I use 0.8? When do I use 1.25? Okay. This one here, you always use 1.25. Okay. If you can't remember this, write this in your code book. Okay. So let's do another example. Let's see here. Scroll down here. And let's see here. I got a 21 amp. Well, we're going to do 26 amps. Okay, 26 amps and of continuous, and I have non-continuous of 12 amps. We're expanding this. Okay, so we take the non-continuous amperage, the full thing, plus 125% of our continuous amps, right? 1.25, and that's going to give us our final breaker. So we take 26 times 1.25, which 26 times 1.25 is 32.5, and we're going to add it to 12, which that gives us, looks like it's 44.5 amps. Okay, now to get our breaker, what's our next standard breaker size? I'd have to look. I don't know if there's a 45. I don't know if it's off the top of my head if it's 45. I think it goes from 40 to 50. So I'm going to make the presumption that there's not a 45. It goes from 40 to 50. So we're going to use a 50 amp breaker. Okay. Notice we mixed and matched. We can use this process right here, this formula, whether we have a combination or not. I hope this helps. Please let me know if I need to expand on this in any way. Have a good day.